We're still solving trig equations, but today's equations are going to be a little bit different. The difference, all of the equations that we solved before, the angle was only x, or theta. Now the angle is going to be like 2x, or x divided by 2, or 3x, or something like that. You'll have something else with the angle. Let's take a little detour for a second. If I'm talking about cosine of x over 2, okay, remember in chapter 4 we did all the graphing of those trig functions, and we know that normally, and you don't have to write this down, but a normal cosine graph we have a high point of 1, low point of -1, so remember cosine started up high and came down. And so this is what cosine looks like. Okay, we remember that? When I talk about cosine of x over 2, when I graph that, my amplitude is still 1 because that's your coefficient. The period is normal period of 2 pi divided by the coefficient of x. X over 2 is like 1/2 x. It would be 2 pi divided by 1/2, which is 4 pi. So that means our count by period divided by 4 is just pi. So when you go to graph that, your points, 0 is your first one, and then 1 pi, 2 pi, 3 pi, 4 pi. And so that graph looks like this. When you have something multiplied with your x, it changes the period, how long it takes for your graph to repeat. It's a really bad curve, but so in this case, it stretched it out. So we can't really just get the solutions from 0 to 2 pi, because is that even one full cycle of the graph anymore? No. So it changes things. Now, there are a couple ways of doing this. We could use that period to solve it. But what I like to do is just solve it like normal, and we'll worry about the difference in the angle at the very end. So if I wanted you to solve this just like before, we have to get the cosine by itself. So what would we do? And then okay, so then we're still not going to worry about the fact that this angle is different. If I had given you this problem yesterday, we would say quadrants and reference angles. When is cosine positive? Reference angle. We are in radians. So when is cosine radical 2 over 2? Think about your hand trick. Cosine is the square root of the bottom over 2. So that would be at 45 degrees, which is pi over 4. So pi over 4 in quadrant 1 is pi over 4. In quadrant 4, that's 7 pi over 4. Now here's where the difference comes in. My angle is x over 2. So that means x over 2 is equal to pi over 4 and 7 pi over 4. So if you want to solve for x, what would you have to do? So pi over 4 times 2 is pi over 2. 7 pi over 4 times 2 is 7 pi over 2. Part A. I wanted just the solutions between 0 and 2 pi. Are both of these between 0 and 2 pi? If you're not sure, think about, like on your calculator, you can divide. So pi over 2, so if you do 1 over 2, that's 0.5. 0.5 is between 0 and 2. 7 over 2 is 3.5. Is that between 0 and 2? No. So the only answer between 0 and 2 pi is pi over 2. And again, I'm only giving that because I asked for it just on that particular interval. Part B, if I want all solutions. Okay, all possible solutions. When we did this yesterday, we talked about how you have to take your starting one and add something to it. And we were always adding 360 or 2 pi because that was the period. But what is the period of this one? Period is 2 pi divided by the coefficient of x, which is 4 pi. So before this one repeats, it will have to travel 4 pi. So we're going to add 4 pi k, where k is an integer. Another way to think about that, if you struggle with that part, you could think, okay, well my original one, if I said x over 2, it is pi over 4 plus 2 pi k. When you multiply by 2, you get pi over 2, and 2 pi times 2 is 4 pi k. So that's where it comes from. If we think about the graph on this, we can confirm. When we graph this, between 0 and 2 pi, it only hit that value one time. But it doesn't hit it again until we get all the way over here. So that's where the second one came in. What questions do you guys have for me here? Let's try another. Okay, I'm going to draw a graph to kind of explain something that's happening on this one. So we're not going to have to graph every time. It's just part of my initial explanation here. So we know sine normally looks like this. It starts at 0, goes up to 1, back to 0, and down. This problem has a sine of 3x. What's the amplitude on that one if we were going back through our graphing stuff? 1. Period. Normal period for sine is 2 pi divided by 3, the coefficient of x. Count by. You do your period divided by 4 for the 4 quadrants, and we get pi over 6. Okay, so this is changing things quite a bit. We're going to count by pi over 6. That's like 30 degrees. So start at 0. Pi over 6 should be up. Pi over 3, back to 0. Pi over 2, you're at -1. So when I graph this, when I get to 2 pi over 3, that's my graph. When I go to solve this, we're going to come back to this graph in a second. So if we were trying to solve this, we just have to ask ourselves, all right, when does sine equal -1? Think about your unit circle. Sine is the y. Where on that circle is y -1? So our angle, 3x, equals 3 pi over 2. All right. If you divide by 3, you get pi over 2. So that's all well and good. I have a solution, but I actually don't have all of my solutions. Because if I look at this, yes, at pi over 2, we were at -1. But if I ask for all the solutions from 0 to 2 pi, wouldn't this repeat again before you got to 2 pi? My period is 2 pi over 3, so at 4 pi over 3, we would have another complete cycle. And so it would repeat again in there. I'm not going to be real precise this time. And then if I add 2 pi over 3, that's 6 pi over 3, which is 2 pi. So how many times does it actually hit -1 between 0 and 2 pi? 3. And that's because of this, that 3 shortened the period. So it's actually telling you between 0 and 2 pi, you get 3 complete cycles of the graph. You know, on the previous problem, we didn't have that issue because it was a 1/2. Between 0 and 2 pi, we only had half of our graph. So this one, between 0 and 2 pi, we have 3 of our graph. So when I see this, when I have that 3, I'm going to make a note to myself. This will be triple the solutions. Because that 3 will give me 3 complete cycles. Okay, there's a couple ways to get those solutions. I find that the easiest is to do it back here before we solve for x. So we got 1's answer. If we're going to have triple, we need 2 more, right? Easiest way to get that is just to add 2 pi to these. So thinking about a complete rotation around. So 3 pi over 2 plus 2 pi, remember from graphing, if you get confused with these, you can use a calculator. You can't put in the pi, so you could do 3 over 2 plus 2, or 2 pi is like 4 pi over 2, so that would be 7 pi over 2. And we're going to add 2 pi again, so that gives us 11 pi over 2. So as long as you do it before you solve for your x, you can just add 2 pi to all of your solutions. Now, to get x by itself, what do? Divide by 3. So we divide each of these by 3. So again, you could use a calculator, don't put in the pi, or you could think multiplying by 1/3. So we get pi over 2, 7 pi over 6, and 11 pi over 6. And those are my answers between 0 and 2 pi. Now, like I said, there's other ways to get it. I don't want to confuse you by throwing out too many options, but if this doesn't make sense, tell me and I can give you another option. So we knew there were triple solutions because of the 3. If it had been a 4x, we would have had 4 times the solutions. To get the remaining ones, before we solve for x, so back when we're still just treating it like a normal 0 to 2 pi, we add 2 pi until we get all of our solutions, and then we can divide all of those by the 3. Now, if I said for all possible solutions, remember, the initial solution was just the pi over 2, right? We only had the extras because we added on for the triple solutions. So it's pi over 2 plus the period. So normal period is 2 pi divided by 3, so we could say plus 2 pi over 3k, where k is an integer. Grab a calculator real quick. I want to show you something. So if we add this, I want you to do what's 1/2 plus 2/3. Okay, so that's why I didn't have to list this one. And if you did 7 pi over 6 plus 2/3. You get the 11 pi over 6. Okay, so these other two are just a result of adding the period. Okay. I know this is kind of confusing. That's why we're just starting. We have more examples to come. But what questions do you have for me right now?
How do we get to, like on the 3x equals 3 pi over 2, how do we get the 3 pi over 2?
That's when we ask ourselves when the sign equal -1. Other questions? Let's try another. That's not the example, is it? What do you notice about this? Has sines and cosines. So two trig functions, which is a problem. What else do you notice? Look at your angles. Sine has an angle of x, but cosine has an angle of 2x. We need these angles to be the same before we can solve it. So they either both have to be a 2x or they both have to be an x. If you think about last chapter, your flip chart, cosine 2x, that's a double angle. Don't we have a double angle formula for cosine? I think we have 3, actually. When you're choosing your formula, since my other trig function is a sine, we need the formula that only involves sine. So now we no longer have weird angles, so this is now just like a problem from yesterday. So quadratics, we want everything on one side, so we could add over the 2 sine squared x plus sine x and subtract your 1. So then we can do box method. So what multiplies to -2 and adds to +1? Mm-hmm. So factor, we get 2 sine x minus 1 sine x plus 1. Right. Now we have two things multiplied equal to 0, so we set each one to 0. Right, again, my angles are x, so this is like normal. I'm not going to have double or triple solutions. I'm not going to have solutions that don't fit in my interval. We're just quadrants and reference angles. When is sine positive? Reference angle. When is sine 1/2? And we were in radians. 1/2 would be at 30 degrees, which is pi over 6. Okay, so pi over 6 in quadrant 1 is pi over 6. In quadrant 2, that's 5 pi over 6. Right, second one, sine x equals -1. We don't even really need quadrant reference angle because that only happens once. Think about your unit circle. Sine is the y. When is y -1?
3 pi over 2.
Mm-hmm. Those are my answers. I'm going to try 1 or 2 more for today, and then we'll pick up tomorrow and continue on. Would I have to use a double angle formula this time? No. You could, but because this is my only trig function, I could just get it by itself. So if we divide over the square root of 2, that would be like saying negative square root of 2 over 2. Quadrants, when is cosine negative? Reference angle, when is cosine radical 2 over 2? And since we're in radians, we'll do pi over 4. Now, what does this 2 theta tell me about my answers? Yeah, we'll have double the solutions. It's basically telling me between 0 and 2 pi, I will have 2 complete cycles of cosine. All right, so my angle, 2 theta, equals, in quadrant 2, pi over 4 is 3 pi over 4. In quadrant 3, it's 5 pi over 4. Those are my original solutions that came from my quadrant and reference angle, but we said double. So we have 2. If I double that, that means I should get 4 total. How do we get those other solutions? Yes. As long as you do it before you divide the 2 over, you can add the standard period of 2 pi, because right now we're still treating it like the unit circle. So 3 pi over 4 plus 2 pi, or 3/4 plus 2 is 11 pi over 4. 5 pi over 4 plus 2 pi, or 5/4 plus 2 is 13 pi over 4. So that gave me all of my solutions. Now, I want to know what theta is. So to get rid of the 2, we have to divide by 2. That means you are going to divide every one of those by 2, or multiply by 1/2. So that gives us 3 pi over 8, 5 pi over 8, 11 pi over 8, and 13 pi over 8. You can do a quick check. 13 pi over 8, what's 13 divided by 8? Is it smaller than 2? Yeah, so it's still just between 0 and 2 pi. We didn't go too far. Like I said, there are other ways to think about this, but I don't want to confuse you by throwing 3 different options out at the beginning. But if, as we go through these, this method isn't clicking, let me know and I will give you an alternative. Okay. Let's do one last problem for today. Am I going to have to worry about double solutions or anything on this? No, because all my angles are just x. However, it's not easy to solve right away because we have 2 different trig functions. So let's replace one of those. Doesn't matter which. Let's say I wanted to get rid of sine squared. What is sine squared equal to? 1 minus cosine squared x from that Pythagorean identity. So I'm going to get 2 cosine squared x. If I distribute my -2, so minus 2 plus 2 cosine squared x plus 1. So if I'm solving for cosine, I would add over my 1 and divide by 4. How do you get rid of a square? And when you do that, you need, so I get cosine x equals positive or negative, square root of 1 is 1, square root of 4 is 2. Okay, since it says positive or negative, that means I have every quadrant, because it can be either one. Reference angle. When is cosine 1/2? So reference angle, when is cosine 1/2?
60 degrees.
Okay, since it's just x, I don't have any double solutions or anything, so these are my answers. So 60 degrees in quadrant 1 is still 60 degrees. In quadrant 2, 180 minus 60 is 120. Quadrant 3, 180 plus 60 is 240. In quadrant 4, 360 minus 60 is 300. That's my answer to part A, everything between 0 and 360. Part B, for all solutions, what's my period on this one? 360. So you could do each of these plus 360k. We're going to stop here. Tomorrow we will practice more. Do you have any questions for me so far? So I'm only going to give you a couple problems to start, and then tomorrow I will add to this. So there's 4 problems.